Hello, welcome everyone to the AstroBit podcast, brought to you by your home for curated space news, astrobitica.com. I'm your host, Alan, the Astro Writer, and this is the next episode of Astro Wife Asks. In this segment, my lovely wife, Raylene, say hi.
Hi, everybody.
Ask me about an astrophysical, astronomical, or space-related subject she's curious about, and I do my best to explain it. It's a fun way to dive into the wonders of the cosmos while keeping things approachable and conversational. So, without further ado, Astro Wife, what do you want to ask about today?
So today I would like to talk a little bit about moons, because there are so many moons in our solar system. But the main thing I would like to know is, what is a moon exactly, and how is it different from a planet?
Okay, so a moon is a natural satellite of a planet. So remember we talked a couple weeks ago about Pluto and why Pluto's not a planet, right?
Yeah.
And one of the things to be considered a planet is that you have to orbit a star, right? So like all the planets that we call planets orbit the sun directly. Well, a moon is a natural satellite, which means it's not an artificial satellite. It's not man-made like a communications or an imagery satellite. And it's natural, so it's an asteroid or some other type of body that gets captured by that planet, and then it orbits that planet as that planet orbits a star. So that's why we call it a moon.
And so why do some planets have dozens of moons while others have none?
It's not only dozens. We have a couple planets that have hundreds of moons, right?
Well, why don't we start from the first planet and then talk about all the...
Yeah. Well, it's largely based on your size, right? So how big your planet is determines what's called its gravity well, how strong its gravitational force is to capture objects or hold them in orbit, and that kind of helps determine how many moons you have. So if we're working from the inside out, the first two planets, Mercury and Venus, they don't have any moons.
At all?
No, not one. And then you get to Earth, obviously. Earth has one moon, and our moon is actually kind of out of proportion to what we consider the size relation to moons and planets are. Our moon is much, much bigger relatively compared to Earth than a lot of other moons are. And that's because Earth's moon used to be a planet.
Seriously?
Yeah. So I don't know the exact time scale, right? Millions, maybe billions of years ago, right? There was a Mars-sized planet between Earth and Mars called Theia. And Theia collided with Earth, and this was, billions and billions of years ago, collided with Earth, and Earth absorbed a lot of Theia, but what was left over of Theia was molten lava out there floating around in space because it was so hot, because collisions are hot. And after it cooled, it formed into what is now the moon. That's why our moon is so much larger than other moons, like compared to the size of the planet they orbit, because our moon was originally a small planet called Theia.
So that would probably happen if, like, Pluto and what's the planet they both... Charon, like if one of them collided into the other and a piece broke off and started orbiting.
Yeah, absolutely. So we talked about before, Pluto only has one main moon, Charon, and really Charon is also relatively much larger, right? Because really Charon and Pluto are kind of like a biplanetary system. They're actually like two planets more than they are like a planet and a moon.
Don't they orbit each other?
Yeah, they orbit the space between each other. So Charon, the moon, doesn't really orbit Pluto so much as they orbit the empty space between each other. But yeah, theoretically, if one were to collide into the other one, Pluto is unlikely to absorb the entirety of Charon. It might absorb a good bit of it, and then there would be the leftovers that, over billions of years would eventually cool and collapse into a ball-like structure, and that would be a new moon.
Oh, so our moon used to be another planet, and that's why it's so large compared to Earth.
Cool. Moving out, Mars has two moons, Phobos and Deimos. All right, Mars's moons are unique because unlike our moon that used to be a planet, right? So it's huge. Mars's two moons, we believe, are captured asteroids. Asteroids that were just, zipping around the solar system, and they got a little too close to Mars, and Mars captured them in his orbit, right? So he has two moons. They're really, really, really small comparatively. They are not round They are kind of potato shaped. They're odd shaped because their gravity is not so large as to collapse them into a ball shape. So gravity hasn't really worked on them enough. And one of them, Phobos, is inching further and further away from Mars every year, and Deimos is inching closer and closer to Mars every year. So that here in like a couple million years, Phobos will fly away completely and be a free asteroid again, and Deimos will crash into Mars. So, if we're around in like 10 or 15 million years, we will see Mars without any moons.
That's probably why you never hear about the moons of Mars. And then, of course, the best planet has the most moons.
Well, not so fast. Jupiter does have a lot of moons, but it does not have the most.
Really?
Yeah. So Jupiter has like 95 moons, right? A lot that we've looked at. Now there's four that are like the most common, and we call those the Galilean moons because they were
Mm.
discovered by Galileo. And those are the largest four moons as well. There's Io, Ganymede, Callisto, and Europa. And those are the four big ones. They're all kind of unique in their own way. We always talk about Europa because it has this possible ocean underneath
Mm-hmm.
its surface. We've talked about that before. But then the rest of the moons, again, are not nearly as large as the Galilean moons. They're also probably captured asteroids that are just kind of locked in Jupiter's gravity well. The most moons goes to Saturn. Saturn, we've long known, had about 147 moons. Recently, and I mean as of just like a couple weeks ago, we potentially discovered another 100 plus, like 120 plus. They haven't been like totally confirmed yet. So theoretically, Saturn could have like 200 and something moons, but we know for sure it has like 140 moons. So it has the most.
How big does a body need to be in order to be classified a moon?
So as long as it is orbiting that planet, like even if it's small, right? Like Phobos and Deimos around Mars are really, really small asteroids. They're only like a couple kilometers wide, so really small. But as long as they are orbiting that planet, then it's a moon. It's a natural satellite of that planet.
So it's not as strict as like planetary
No,
definitions.
not yet. Now, again, maybe someday we try to reevaluate the definition of what is a moon, just like we redefined what is a planet. But for now, that's really the only criteria.
So does Saturn have very specific types of moons like Jupiter has that are noticeable?
Yes, it has a couple big ones. Titan is the big one. Then there's Enceladus. Enceladus is pretty cool because of the gravitational force that Saturn exerts on Enceladus. It causes the like the surface of that moon to like crack and open, and we believe or we've observed these ice plumes that like they're like these volcanic eruptions of ice and that like spray out into space because there's no atmosphere like holding it in, so it just sprays out into space. And we've seen those like there's the Cassini spacecraft that flew around Saturn for a long time, took pictures of these giant ice volcanoes from the planet of Enceladus shooting out into space. It's really awesome.
So how do all these moons orbit around Saturn given that Saturn has rings?
So there's a thing called the Roche limit when a natural object, right, when a natural satellite like a moon or an asteroid gets close enough to a planetary body, it will break apart, right? And when it breaks apart, it forms a ring, right? So the objects, and we believe there were asteroids and other moons that created Saturn's rings, just crept closer and closer and closer till it hit the Roche limit, and they all broke apart and formed this giant ring system.
Could
So if you're outside that Roche limit, but you're still under the influence of that planet's gravity, then you can orbit it while you're intact and be a moon. But if you start inching closer and closer, you'll break apart.
theoretically could the moons that Saturn has eventually become part of the Roche limit of
Yes, if
Saturn?
they creep closer and closer, we don't think so. We think their orbits are relatively stable.
Oh.
But if they do, for if some other influence out there, like knocks one in closer to Saturn's orbit and it hits Saturn's Roche limit, then yeah, it could absolutely break apart and be part of Saturn's rings. Saturn's rings are also slowly collapsing into the planet itself,
Like
right?
Jupiter's red spot is disappearing.
Yeah, exactly. Um, and Saturn's rings, because they're inside that Roche limit, Saturn is slowly drawing them in, and they will, bit by bit, they're like little grains of sand, really. Bit by bit, they will collapse into the planet. So again, if we're around a couple billion years from now, you might look at Saturn and it won't have any rings.
Why do millennials always find out the most depressing things? Pluto's not a planet anymore. Saturn's rings are collapsing. Jupiter's red spots are disappearing.
It is the nature of the universe.
Well, at least it's only a couple of million years ago away. I mean, it's fine. Um, what's next? Uranus.
Uranus, yeah, Uranus has a couple of big ones. The most one people know about is Oberon. It's a pretty large moon. And then Neptune has one major one, Triton.
Only one?
No, it has several, but
Oh,
the major. When we talk about a lot of the gas giants, they have so many moons, but most of them are captured asteroids or captured
they're not really
comets. Yeah, they're
noticeable.
not really noticeable. When we talk about the moons of these planets, we mean like their larger bodies.
Mm.
For example, Ganymede, which is one of Jupiter's Galilean moons, is actually the largest moon in the solar system. It's larger than our moon. Ganymede is actually larger than the planet Mercury. It's huge. So if Ganymede were to break off and start orbiting the sun directly instead of orbiting Jupiter, it would be a major planet in the solar system.
We'd have a new planet. Okay, so back to our moon. Do you think humans could ever live on the moon?
Yeah, absolutely. So this is a big thing for me. I know everybody likes to talk nowadays about humans got to go to Mars and we have to go to Mars.
Eh,
And, I'm not going to lie. It would be awesome to have humans on another planet, right? But really, if we're talking about long term exploration of the solar system, if we're talking about putting humans in space for long durations, the moon is really where we need to go, right? The moon is rich in what we call these rare earth minerals, like minerals that we find here on Earth, but in really small quantities. The moon has a lot of them, right? And it's easy to get to the moon. It only takes you about 2 or 3 days versus Mars takes you about 6 months. We've studied the moon a lot over the last several decades, so we know what its composition is. We know where the best places to go are. We believe there's frozen water on the moon at the poles, so we could extract that and use it. There's a lot of good opportunity for us to get to the moon. We say in space travel, the hardest part about space travel and the most expensive part is getting off Earth, because Earth has a huge gravity well, and when you're blasting a rocket off Earth, 90% of its fuel and resources are used just to get it off Earth and then into space. Well, if you could get off of Earth and then just quickly land on the moon and gather more resources, that would be a much more efficient way to build things in space. It's like a stepping stone kind of thing.
kind of like a International Space Station Midway.
Yeah, but on the moon.
Yeah.
Yeah, that would be great.
Yeah, I think we should probably look towards the moon first before we look towards Mars. Why does the moon always show us the same face?
So the moon is close enough to Earth that it is tidally locked, which means it shows us the same face all the time. If it were a little bit further away, its rotation might be more pronounced. But because it is so close to Earth that Earth's gravity kind of locks it in place, that's why it shows us the same face all the way around. That's why there's all these theories about the dark side of the moon. Like
Mm,
we've seen the dark side of the moon. Okay, we have satellites that have imaged the dark side of the moon. There's nothing crazy out there, but yeah, that's why when you look up at the moon, it basically looks the same all year round.
it's pretty impressive how one moon out there in space influences all the tides on Earth and everything.
Yeah. So one other thing, we've talked about exoplanets before, right? How we
Mm-hmm.
look at for planets outside our solar system. There are a group of scientists that are also looking for exomoons, moons outside our solar system. Because while we have seen, hundreds of planets outside our solar system, we've looked all over, right? And I mean, there's a rich catalog of exoplanets that we've discovered. We have yet to discover an exomoon, a moon outside the solar system. So there are people that are on the hunt for that because theoretically, I mean, moons should exist everywhere.
Yeah.
We see bodies orbiting larger bodies all the time, but there is no evidence yet of any moons outside of our solar system. Now, that's probably because moons are really small compared to planets, so they're much harder to image. They're much harder to differentiate their gravitational force in the data. But we have yet to discover an exomoon, and hopefully that happens here in the next couple of years, and that will be pretty big news when it does happen.
It's probably just our technology is not good enough to see it yet. Which moon would you visit and why?
Uh, Pretty typical. I'm gonna go with Europa, right? Because Europa, yeah, it's frozen. It's a frozen ice ball basically. It's got this large icy outer shell, but we believe that the internal forces of the planet have are warm enough to melt that icy water and keep it liquid. And we think there's a liquid ocean under that icy shell of Europa, right? And we've talked about in previous episodes about what does it need, what does life need to take root, and we know one of those things is liquid water and warm enough temperatures, and those conditions might be in the center of Europa somewhere. So that's the one. If I could go visit, I would try to take that and some drilling equipment and try to drill as deep under the ice as possible to take a sample, because if there's any chance of some other simple life form out there in our solar system, it would be on Europa.
Neither.
What about you? Where would you go?
Maybe Io, because I used to want to be a volcanologist when I was younger. And that one's volcanically active.
Very volcanically active. It's actually the most volcanically active body in the solar system.
Or maybe Titan, mostly because I like the name. Yeah, one of those two. But I think Io would be top of my list because, Jupiter's moons and
You would get a really good view of Jupiter from Io's surface. You would have to dodge some pretty epic volcanoes and lava flows, but you would get a really beautiful view of Jupiter while you were there.
That'd be cool.
Okay, thanks so much for tuning into this episode of the Astrobit podcast and this episode of the Astro Wife Ask. I hope you enjoyed our conversation and maybe learned something new along the way. If you want to explore more curated space news, don't forget to check out astrobitica.com and follow us for updates on future episodes. Until next time, keep looking up and stay curious.
Bye, everybody.